All right, so in lesson 9, we're just continuing which variable to solve for. So in lesson 8, we talked about when it specifically asks us to find something, that's what we need to have our equation set equal to. So 9.1 starts out right with faces, vertices, and edges. It says, in an earlier lesson, you saw this equation. So this was way back at the beginning of this unit. Oh gosh, let me try that again. The V plus F minus 2 equals E, which stands for vertices plus faces minus 2 equals edges, which relates vertices, faces, and edges in platonic solids. Okay, so here's a little example of platonic solid down here. So what it wants you to do, it says, let me zoom in a little bit so you can see this. It wants us to write an equation that makes it easier to find the number of vertices. Okay, so there's that keyword again, find the vertices. So it's wanting us to solve our equation for V. Okay, so all we're doing is writing an equation where it did not ask us to solve anything. So let's look at A. It says an octahedron, which is this shape right here, has 8 faces. Okay, so they told us a very important variable. They told us that F equals 8. Okay, so I'm going to take my equation that they gave us, V plus F minus 2 equals E. All right, so I have an equation, I have a variable. What can I do? I can substitute it, okay? So everywhere I see an F in my equation, I can substitute it for an 8. So I have V plus 8 minus 2 equals E. Well, right here, I notice that I can go ahead and simplify this part right here because 8 and 2 are like terms. So I have V plus positive 8 minus 2 is going to give me a positive 6, and that equals E. So now that I have my equation simplified, I have to remember what it asked me to do originally. It said write an equation that makes it easier to find the number of vertices. If it wants me to make it easier to find the number of vertices, then I need to get my equation solved for V. And if I'm going to solve my equation for V, I need to get that V all by itself. So if I want to get that V all by itself, I start with my term that's farthest away, which is this positive 6. So how am I going to get rid of a positive 6? I'm going to subtract 6. If I subtract 6 on one side, I have to do it to the other side to keep my equation balanced. Okay, so that's going to cancel those 6's out. I bring my V down. Can I combine an E with a minus 6? No, I cannot. They are unlike terms. This one has a variable, this one does not. So it just leaves it as E minus 6. And that is my answer. Remember, it didn't ask me to solve anything. It just wanted me to write an equation that made it easier to find the vertices. So now I have an equation that's set equal to vertices, and that makes it easier to find. All right, let's look at part B. It says an isosahedron, which has 30 edges. So this time it told me my variable for E, which is 30. You're going to have to write really small on this one. They didn't give you a lot of room. So I'm going to take my equation that they started with, V plus F minus 2 equals E. I have an equation. I have a variable. What can I do? Substitute. Okay, so everywhere I see an E, I'm going to substitute it for 30. So I have V plus F minus 2 equals 30. All right, so is there anything I can simplify before I move on to the next part? Do I have any like terms with V? No. Do I have any like terms with F? No, no other F's. All right, but I do have 2 whole numbers by themselves. So I want to get this minus 2 over here with my 30. So how can I move that minus 2 over to the other side? I can add 2 to both sides. So that's going to cancel the 2's out over here, Now I have V plus F equals 32. Okay, so now that it's in its most simple form, I have to once again remember what it's asking me to do. We're trying to make it easier to find the vertices. So I've got to solve for V. I'm going to take this and rewrite it up here so I'll have a little bit more room. So I'm trying to solve for V. So that means I need to get this V all by itself. So I start with my term that's farthest away. I have a plus F. So I need to get that plus F and I need to move it over here to the other side. So in order to do that, I'm going to subtract F. If I do it to one side, I gotta do it to the other side. So that's gonna cancel my F's out and I have V equals, well, I can't combine these two terms because they're unlike once again. So I have 32 minus F. And that is my answer. I just wanted an equation that would make it easier to solve for the vertices, and that's what that is. So that's our answer. Okay. Next, it says we have a Buckminster fullerene. Do not know if that's how you actually say it. Also called a buckyball. It is a polyhedron with 60 vertices. It is not a platonic solid, but the number of faces, edges, and vertices are related the same way as those in a platonic solid. So basically that next sentence is just to say that we can still use V plus F minus 2 equals E. We can still use that equation to represent a buckyball. Okay, once again, here we are. It wants us to write an equation that makes it easier to find the number of faces. So what's it wanting us to find? Faces, which is F. Okay, so they want us to take our equation and they want us to solve it for F. But before we do that, we need to simplify and plug in what we know. So I have V plus F minus 2 equals E. All right, so they also told us a very important piece of information earlier on. They told us the number of vertices. So they told us that V equaled 60. So I have an equation, I have a variable, what can I do? Substitute. So everywhere I see a V in my equation, I can substitute it in for 60. So I'm going to go ahead and do that. 60 plus F minus 2 equals E. All right, well, I immediately see that I have two numbers by themselves, so I can combine those. So keep in mind, that says 60, a positive 60 minus 2. Okay, so a positive 60 minus 2 would give me a 58 plus F equals E. Okay, so now I have it as simplified as it will go, but I need to remember that I'm trying to make it easier to solve for F. So I need to get that F by itself. So I need to get this term, this 58, away from it. So I have a positive 58, so I'm going to subtract off 58. If I do it to one side, gotta do it to the other side. It's going to cancel those out. I'm left with F equals, can't combine E and 58, so it's just E minus 58. And that is my equation that makes it easier to find the number of faces. Okay, so hopefully you're seeing that pattern, and this was just a good little activity with just some simple 1 or 2 step equations to solve, but we're going to continue doing that as we move forward. So if you don't understand it yet, we have this lesson, we have a lot of the questions in this lesson are really, really good, so it'll be fun. All right, so we have 9.2. It says an automobile manufacturer is preparing a shipment of cars and trucks on a cargo ship that can carry 21,600 tons. Okay, I'm going to try to color coordinate this for us. It says cars weigh 3.6 tons each, and trucks weigh 7.5 tons each. It wants us to write an equation, not solve anything just yet, just it wants us to write an equation that represents the weight constraint, which is that 21,600 of a shipment. Keep in mind, I'm color coordinating. We're going to let C be the number of cars, and we're going to let T be the number of trucks. All right, so if I'm setting up this equation, I already know on this cargo ship that I'm going to be dealing with my cars and I'm going to be dealing with my trucks. So if I have one car, I know it's going to weigh 3.6 tons, but I want you to think about for a second, if I said we were going to have 42 cars on this ship, okay? In your head, in order to find out how much that weighs, what mathematical operation would you do to find out that weight? You would multiply it. But in this particular case, that doesn't tell us the specific amount of cars. So in order to show that in our equation, we're going to take the weight of the cars, 3.6, and we're going to multiply it by the number of cars we have, which is C. Okay, same for the trucks. We're using T to represent trucks. And if I had one truck, it's going to be 7.5 tons. But if I told you we're going to have 562 trucks on the ship, then you're going to take 7.5 tons and you're going to multiply it by however many trucks we have. Okay, but once again, like I said, we don't know how many trucks we have. So we're just going to take that 7.5 and multiply it by the number of trucks we have, which we use it as T. So this part is going to tell us the weight of all of our cars. This part is going to tell us the weight of all of our trucks. And if we want to know the total weight that is, we're going to take those two things and we're going to add them together. And once we do that, that's going to equal our weight constraint, which is 21,600. So that is our equation for this problem. So we're going to use this equation for the next little bit. So keep that in mind. It says for one shipment, trucks are loaded first and cars are loaded afterwards. Even though trucks are bulkier than cars, a shipment can consist of all trucks as long as it is within the weight limit. Okay? So it says find the number of cars. So because it says find the number of cars, we know that we're going to be solving for C. So just so we don't forget, I'm going to rewrite that equation back here on the top of my paper, so you should too. Okay, and also there's a lot to this problem, and I had to do this in all my classes too. You need to take your paper and you need to split it up like this, because you will run out of space and it will get very sloppy very quickly if you don't. You're also going to have to write very, very tiny. Okay, so I'm going to do this first one with you, and then I want you to do B and C on your own. Okay, so this tells us that we have 480 trucks. So they just told us the number of trucks, which we know we use T to represent. And it wants us to find the number of cars. So it wants us to solve for C. They gave us T, they want us to solve for C. Okay, so going into my paper, I'm going to take my formula, 3.6. Keep in mind, I'm writing very small to fit this in this little bitty section. If you want to get out a separate sheet of paper to solve it, you go for it. Okay, I have a variable. I have an equation. What can I do? I can substitute it, okay? So I'm going to, everywhere I see a T, I'm going to substitute in 480. So I have 3.6 C plus 7.5 times 480, and that equals 21,600. Okay, so before I start trying to get this C all by itself, which is what we're trying to do, I can simplify this a little bit. I have 7.5 times 480. Okay, so I'm going to simplify that really quick. 7.5 times 480. And that gives me 36,000. Okay, so I'm going to bring down everything else. Okay, so now what I'm trying to do is I'm trying to get that C by itself. So when I do that, I start with my term that's farthest away. How am I going to get rid of a plus 3,600? I'm going to subtract 3,600. If I do it to one side, I have to do it to the other side. Those cancel out. I'm left with 3.6C equals 21,600 minus 36 is 18,000. Okay, still got to get that C by itself, so I need to divide both sides by 3.6. Divide by 3.6, those are going to cancel each other out. And when I have 480 trucks, I can have 5,000 cars on my shipment, on my cargo ship, without it going over the weight constraint. All right, what I want you to do now is I want you to pause the video. I want you to attempt to do B and C, and then I'm going to continue working them, but I'm just not going to talk my way through them. I'm just going to write them out, and I want you to make sure you check your work and see if you did your math correctly. Already writing too big. Okay, so double check your answers, make sure you did all your math correctly. Hopefully you notice a pattern, like we did the process the same every single time. So now it wants us to take it and it wants to solve it for T, or for T amount of trucks. Okay, so what it's wanting us to do is to take our original equation. We have 3.6c plus 7.5t equals 21,600. And it's still wanting us to solve for C. That hasn't changed. It still wants us to find the number of cars, but it wants us to find it for any amount of trucks. So this saying this value could change. So we're going to just keep it as T this time. So we're not going to be able to solve necessarily. We're only going to be able to rearrange the equation. Okay, so keep that in mind. We're not solving anything because we can't solve an equation that has two unknown variables in it. The only thing we can do with an equation with two unknown variables is rearrange it to solve for something specific. So we're still solving for C. So if I'm trying to get C by itself, then I need to start with the term that's farthest away. So how am I going to get rid of this positive 7.5t? I'm going to subtract 7.5t. So if you look back at any of the problems we just did, that was our first step anyways. We subtracted off the product of 7.5 and however many trucks we had, which is what we are doing once again here, except we don't know how many trucks it is, so we can't simplify it. All right, so if I do it to one side, then I have to do it to the other side. Those cancel each other out. I have 3.6c equals. I cannot combine these two terms. This one does not have a t. This one does have a t. They are unlike terms. So I'm just going to have to write it all out. Alrighty, now I have 3.6 times c, so I have to divide both sides by 3.6. Divide both sides by 3.6, which once again is the same step we did in all the other ones. That's going to cancel this out here, and I'm left with C equals 21,600 minus 7.5t, all divided by 3.6. So this equation now, if I know how many trucks I have, I can just substitute that in there, and I can solve it for C. Okay? So remember this process here because we are going to do it for the next couple of lessons. So don't stress if you don't understand it right now, that rearranging of the equation, but trust me, you will understand it the more you keep doing it. So number 3, still talking about this ship. It says for a different shipment, cars are loaded first and then trucks are loaded afterwards. Write an equation that you could enter into a calculator spreadsheet to find the number of trucks. So this time it wants us to make it easier to find T. And it can be shipped if the number of cars is known. Okay, so there's not enough room to do this part right here. So I came over here to like the margin of my paper in my other classes. So I would recommend writing it there. Okay, so I'm going to start off with my equation again. 3.6c plus 7.5t equals 21,600. So because they wanted to make it easier to find trucks, we're going to take my equation and we're going to solve it for trucks. Okay, but this time it doesn't tell me what C equals like all the other things. So we're just rearranging it. Okay, so if I'm solving for T, I start with my term that's farthest away, which is 3.6c. So I'm going to subtract that off because it's positive. If I do it to one side, I got to do it to the other side. Very similar to what we did right over here in D, except it's the other term. Okay, so I have 7.5t equals, I cannot combine these two terms, so I'm just going to leave it as 21,600 minus 3.6c. So that's 7.5 times t, so I'm going to divide both sides by 7.5. My 7.5s are going to cancel out. And I'm left with, well, I won't write it here. I'm going to write it actually in the question. I'm left with T equals 21,600 minus 3.6 C, all divided by 7.5. So that is my equation for trucks, to make it easier to find trucks. All right, so in B, it wants us to use that equation and a calculator computer to find the number of trucks, okay? That can be shipped if it already has 1,000 cars, and then again if it has 4,250 cars, okay? So we're gonna call this part A and this part B. So take your little paper and section it off. We're gonna part A, part B. Okay, so it tells us that C equals 1,000. So it says use your equation. So we have an equation, we have a variable. What can we do? We can substitute. So I'm going to just take my equation. I have T equals 21,600 minus 3.6 times 1,000, all divided by 7.5. Okay, so now all you have to do is just plug it all into your calculator in one fell swoop, and it makes it a lot easier to find it. Okay, but now if you're using your phone, you have to follow order of operations. But if you're using your classroom calculator, I'll show you an easy way to type all this in. So when you do it in your calculator, you need to type in all the stuff that's in the numerator first. All right, it's kind of laggy a little bit. All right, so I have 21,600 minus 3.6 times 1,000. Okay, I'm not going to divide by 7.5 just yet. So I'm going to hit enter. I'm going to get everything in my numerator, and then I'm going to divide it by 7.5. Okay, so if I have 1,000 cars, then I can have 2,400 trucks. Okay, then it says for part B, it says how many if you have 4,250 trucks. So you have a variable, you have an equation. Pause the video and see if you can type that correctly into your calculator. All right, if you typed everything into your calculator correctly, you should have gotten 840. If you did not get 840, what must have been how you didn't follow order of operations, or you did not enter it correctly. All right, moving on to 9.3. This is the last part, and then we are finished. It says the Department of Streets of a city has a budget of $1,962,800, and they use that for resurfacing roads and hiring new workers. The cost of resurfacing a mile of two-lane road is estimated at $84,000. The salary of a worker in that department is $36,000. Write an equation that represents the relationship between the miles of two-lane road the department could resurface, which we're going to use M, and the number of new workers it could hire, P, if it spends the entire budget. Now, the way I just highlighted, all right, so the way I just highlighted was for a specific purpose. I wanted you to see, how they're color coordinated. I highlighted certain things that went together and underlined certain things in certain colors that go together. So to match this budget, I know that my budget is made up of how much road we can resurface and how many workers we can hire. Okay, if I'm going to resurface the road, I know that it takes, it takes 84,000 to do 1 mile. So depending on the number of miles, we're going to take those and multiply them. Now for the workers, I know that it takes 36,000 a year. So I'm going to multiply that by the number of workers that we hire. To find the total, how much that's all going to cost, I add those together, and it has to meet within that budget, $1,962,800. So that is my equation for this situation. Yes, I know we're working with big numbers here, but you have got it. It wants us to take that equation and solve for P. So when it says solve for P, it wants us to get P by itself. Okay, so we have 84,000 M plus 36,000 P equals 1,962,800. All right, so we are trying to get P all by itself. So if I'm trying to get P all by itself, I start with my term that's farthest away. So I'm going to subtract off that 84,000 M, and then I have to do it to both sides. Cannot forget to keep it balanced. Okay, those are going to cancel out, and I'm left with 36,000 P equals, I cannot combine these two terms. This term has an M with it, and this term does not have a variable with it at all. So I just have to keep them all the way written out. Yes, I know they are big numbers, but you can do it. Okay, still don't have that P all by itself. I got to get it there. So that's 36,000 times P. So I'm going to divide both sides by 36,000. That's going to cancel those out, and I'm left with P equals, and I'm just going to write it all out, 1,962,800 minus 84,000 M, all divided by 36,000. And now I have solved my equation for P. And I can't do any more with that unless they told me what M or P equaled, because once again, I cannot solve an equation that has two unknown variables in it. All right, so what I want you to do is I want you to do B on your own, pause the video, and see if you can work that out on your own, and then check it when you're finished. I'm going to still work it out, let you check, and see if you got it correct. But make sure you fix it if you do not do it correctly. All right, so that is what you should have gotten for that. So this equation is now solved for M, so that makes it easier to find the number of miles that we're looking for. This one up here helps us make it easier to find the number of people we can hire. So it says this city is planning to hire 6 new workers and use its entire budget. Which equation should be used to find out how many miles of 2-lane road it could resurface? So since we're trying to find out how many miles of 2-lane road, we need to choose the equation that is set equal to just that. So between these two equations that we just figured for P and M, which one is set equal to what we're looking for? The one that solved for M. All right. So then the last question says, find the number of miles of two-lane road. So we are trying to find M, that the city could resurface if it hires 6 new workers. Well, we know that new workers is used for the variable P, and they told us they're going to hire 6. So I have a variable, I have an equation. What am I going to do? Substitute it in. So I have M equals 1,962,800 minus 36,000 times 6 new workers, and then divide that by 84,000. Okay, because this little section right here is going to tell us how much it costs for all the new workers. We're going to subtract that off the total budget, and then whatever's left, we're going to divide it by the 84,000 that it takes to build a new road. So let's go to our calculator. Remember, I do everything in the numerator first. 1,962,000. Oops. 1,962,800 minus 36,000 times 6. That's going to give me everything in the numerator. I get this long number, and I'm going to divide that by 84,000. Okay, so I get 20.79 miles of road. All right, and that is all of lesson 9. Just the importance of whatever it's asking you to find is what you solve your equation for.